Assalamu alaikum wa rahmatullah. Welcome back to problem 3. Problem 3 is about a series connection of inductor, capacitor, and a resistor, all of them connected in series. The inductor has inductance of 40 Henry, the capacitor has capacitance of 20 microfarad, and finally the resistor has a resistance of 200 ohms. They are connected to a voltage with a signal of 2.6 volt. This is the voltage of the circuit, and it oscillates with a frequency of 4 kilohertz. Determine the current supplied and the voltage developed across the resistor. So first of all, get the current. That is your first target variable, the current. Second of all, the voltage developed across a resistor. This is written V sub R. Okay, we will start with circuit diagram as usual. Solution, when you write solution, draw the circuit diagram. Okay, you have a resistor, and the resistance of the resistor is what is it, 200 ohms. And then you also have a capacitor. The capacitance of the capacitor is 20 nanofarad, is given here 20 nanofarad. Then you also have an inductor in the circuit. Okay, the inductance of the inductor is given as look at it here, 40 millihenry. So you write 40 millihenry, and then this series connection is now connected to AC source. So you make the connection like this, and the voltage is 2.6. So you put 2.6 volt, comma, then you give you write the frequency given. The frequency is 4 kilohertz, so we write 4 kilohertz. Now with this we have the circuit diagram. Now when loads are connected in series, remember that the same current passes through them. So the current that passes through this resistor, is the same current that passes through the capacitor, is the same current that passes through the inductor. But the potential difference, the PD across them, the voltage across them is different. This one has its voltage is given as V sub R, and V sub R, how do we get the V sub R? We multiply the current passing through it by its electrical resistance. Also, you have voltage across the capacitor, current passing through the capacitor multiplied by the resistance of the capacitor, which we call capacitive reactance. Also, the inductor has its own PD across it, the voltage across it, V sub L, and is given by current multiplied by inductive reactance X sub L. Okay, before you can get the current, you must get the total electrical resistance in the circuit, which in this case is impedance. But you can get impedance without first calculating capacitive reactance and inductive reactance. So the first thing we are going to do is to get our capacitive reactance and our inductive reactance. Uh, for um, for inductive reactance, X sub L is equal to 2 pi 2 pi FL, you see, then we write 2 pi multiplied by our F. The frequency is given here, 40 kilohertz. So 4 kilohertz, this K is 10 raised to the power of 3, don't forget. So we write 4 and we say multiplied by 10 raised to the power of 3. We have just converted it to hertz. Then our L is the inductance of the inductor, which is given as 40 millihenry. Can you see 40 millihenry? And it's also here. Do not forget that this M is 10 raised to the power of minus 3 milli. So we write times 40 and say times 10 raised to the power of minus 3. Okay, this will give us what? Then we bring our calculator and press 2 pi 2 2 shift we have 2 pi multiplied by 4 exponential 3 multiplied by 40 exponential negative 3. Then you press equality sign. If it gives you in terms of pi, please press this SD and you will be given the value without pi. It will be 1005.31 in ohms, because this is electrical resistance, so it's measured in ohms. Now, after getting your inductive reactance, the next thing is to get your capacitive reactance. For capacitive reactance, the formula is 1 upon 2 pi Fc. This is the formula. So you move on and say this is equal to 1 upon 2 pi times your F is again 4 times, look at it here, 4 times 10 to the power of 3, then multiplied by capacitance of the capacitor. In the problem, we are given the capacitance of the capacitor as 20 nanofarad. Look at it here in the diagram, 20 nanofarad. This N for nano is 10 to the power of minus 9. Don't forget that. So when you put your 20, make sure you also write 10 to the power of minus 9. Then now bring your calculator and you evaluate the denominator. Just focus on the denominator. 2 shift this, then you have 2 pi multiplied by 4 exponential 3 multiplied by 20 exponential negative 9. Then you press this. Okay, after pressing this one, then you know it's in the denominator, so you have to take the reciprocal, press this button, this reciprocal button. Okay, then you press it, you will see answer, reciprocal of your answer. Now press equality sign and you will see your answer here, 1989.43 approximately 44. So this will be 1989.44 in ohms, again because it's electrical resistance. Okay, remember again that your resistance here, the electrical resistance given is 200 ohm in the problem, and you can see it here also in the diagram. So this is 200 ohm. So these are the three resistances you have: one due to capacitor, one due to inductor, one due to capacitor, and the other one from the resistor. Okay, to get the total resistance, we do not just add them together. That's wrong. First of all, we get the difference between x sub L and x sub C. Okay, this minus this. You already obtained this, so you say 1005.31 in ohm minus x sub C, and x sub C is 1989.44 in ohms. And this will give you what? Check. Let's do that. Remember, I am keeping this in two decimal places, correct? Two decimal places. 1005.31 minus 1989.44 will give you, okay, if you are given fraction, okay, this will be negative 984.13 in ohms. Okay, in ohms. Now, to get the impedance, remember the formula for impedance. When you have the R, the C, and the L in the circuit, you say R square plus open bracket x of L minus x of C close bracket square, and this is equal to square root of your R. Look at your R here, 200, so you put the 200 here square, plus then open bracket close bracket square. What do you put inside the bracket? The difference between the two here, and the difference you have calculated it here, can you see? And you got negative 984.13, negative 984.13. Okay, this is equal to square root of 200 squared. Okay, take your calculator and say 200 squared, equality sign, and this is gonna give you 40,000 plus then the second one, open bracket. You see in your calculator you have open bracket, so you press open bracket, press minus 984.13, close bracket, and square it. You see this is what will appear on the screen. See that? And then you now press equality sign and see what you have. It will be a positive number. If you do not get a positive number, do it again. It has to be a positive number. So you have 968511, 968511 point, correct to two decimal places, it will be 0.86. So this is equal to square root of, then you add these two, you have 40,000 plus 968511.86. So this will give you 8511.86. Finally, you press square root of this, so you have a square root, you press square root, and then 1008511.86. Now press equality sign and you will get your answer as 1004.25. you see 0.25 approximately. I'm stopping at the second digit here after the decimal point, so I have 25. And remember, is electrical resistance in ohm. This is the impedance. Without this impedance you cannot get the current. Now that you obtain impedance, you apply Ohm's law to get your current. Ohm's law. Ohm's law says V is equal to IR. So if we apply this to our circuit, we know that this V should be the total voltage we have as V, the signal we are given, and then this I should be the total current flowing through the circuit, and our R should be the total electrical resistance in the circuit, which is the impedance, because it's not, we don't have only a resistor. Remember, we have a capacitor, it has its own electrical resistance. We also have an inductor, it has its own electrical resistance. So when you combine those two with the existing resistor in the circuit, you get the impedance. So this is why the formula changes to V is equal to IZ. And from here I can get my I and say I is equal to V upon Z. And my V from the problem, if we go back to the problem, this is the V, 2.6 V, okay, which we also reflected in our diagram, 2.6 V. So we put that 2.6, we divide it by our Z is the one we calculated here. You see, we started calculating our Z from here. You see all of that, and we got 104.25. So 1004. So we have 1004.25, and this is equal to, we move on and say, okay, this is 2.6 divided by 1004.25. If it gives you in fraction like this, please press this one, it will change to decimal, okay. And what you have here is 2.59 times 10 raised to the power of minus 3. And what you have just calculated is electric current. Electric current is measured in ampere, so you put capital A there, ampere. Now we know that 10 raised to the power of, you can leave your answer like this and it's correct, but to be more scientific, we know that 10 raised to the power of minus 3 is milli, so you can decide to say, okay, this is 2.59. Instead of all this, you put small m for milli and you bring this a, you have 2.59 milliampere. But if you want to use I in later calculations, don't use this one, use this one. The next one, the next target variable, remember the first target variable was current, to get the current. Then the next one is to get the voltage developed across the resistor, which I said is V sub R. If you go back to the diagram we gave, we drew the diagram and we said this V sub R is calculated using this formula. V sub R is equal to IR. Okay, you've just got your I, so you use it to get your V sub R. So you now say voltage developed across the resistor is given by this formula. V sub R is equal to IR. See, you continue and say your I, you got your I here, look at its value, 2.59 times 10 to the power minus 3 multiplied by the electrical resistance. The electrical resistance is 200 ohms. So multiplied by 200 ohms, and now you take your calculator and say, okay, 2.59 exponential negative 3 multiplied by 200 is equal to, if it gives you in fractional form, please press SD, and you have 0.518, and this is voltage. What will be the unit? Volt. You put capital V here. So with this, you have successfully solved this problem 3. The target variable I, you got it here. The other target variable V sub R, you also got it here. I hope this is clear to all of you. May Allah ease our understanding of physics. Assalamu alaikum wa rahmatullah.